So here are just a few thoughts about reflections that I think are quite interesting. So if I have the point A here, and I reflect that across this red line, which we should call L, there's an interesting thing that occurs. The distance between A and line L and A prime and line L will be the same, as we know, because the line of reflection is the point about which you mirror the pre-image A to get the image A prime. So if that's true, then there's something else, though, that I think is quite interesting, and that is line L, so I'll go ahead and write this down. Line L is actually the perpendicular bisector, as you know, of a segment AA prime, or really any point you reflect across. So this little like blue segment here that I'm drawing, this is going to form 90-degree angles with line L, based on really what a reflection is, because it's going directly across that line the same distance. And so you could choose any other point you wanted on line L, right? So let's call this point B, maybe this point C. And what's interesting is the distance from A to point B is going to be the same as A prime to point B, and the distance from A to C is going to be the same as A prime to C. So there's just all kinds of relationships. You could choose any point you want off of line L, and the distance between that point and A will be the same as the distance between A prime and that point. And you can probably see why. You actually get an example of two congruent triangles out of this, because if, for example, C here, if I was to make a segment from A to C, and you can see that I'll color this in white as well, from A to line L, and then down line L, we have a right triangle. And same with the A prime side. We have two congruent triangles, so these hypotenuses here are exactly the same length because they share two common sides. This side is the same as this side, and then of course this side is shared. And so this distance here must be the same. And the same is true for this one up here, or any point on line L.